All right, I'm going to do homework set number 5, and this concerns a plug flow reactor. So consider that we have a tube or a pipe or a canal or a river, and we have flowing through it some water flow Q, and we have a concentration going in and a concentration going out. And those are different because there is some reaction going on, and it's a first order reaction, and so it has formulation of negative Kc. And in this case, that means that as it moves through the plug flow reactor, it decays. And we can think about this as if it was a jar test moving through the system in a plane. That is, the flow through it is going through like a plug, and there's no horizontal mixing. And so there's no dilution going on here. There's only decay, only reaction. So this means that we can model it like a jar test. Or a batch system. And so for a first order reaction, that's like dC v dt is equal to Qn Cn minus Qc minus Kc V, but there's no flows in or out in this case because there's no dilution. Set this to 0. And so then so dC dt is equal to negative Kc, or C is equal to C initial e to the negative Kt. Well, for a plug flow reactor, T is equal to the time to pass through. Which is the hydraulic resonance time of the plug flow reactor, which is equal to the length of the plug flow reactor, the cross-sectional area, divided by the flow. The cross-sectional area is right here. And x is the distance, that's equal to the length. So for this problem, the length, the hydraulic resonance time is unknown. So we're finding the hydraulic resonance time. And remember HRT, same thing as hydraulic resonance time here. So in that case then, we have this solution. So we have C over C in is equal to 0.05. We have 95% removal, which is equal to E to the negative 0.05 times the hydraulic resonance time. So that means that ln 0.05 divided by negative 0.05 is equal to the hydraulic resonance time, which comes out to 60 days.